Hey Techno Studs, in this video we're going to start laying a foundation for what spanning tree protocol is and how it operates. So within our networks we want redundancy. So for an example, we want multiple pieces of equipment doing the same thing, so if one of those pieces of equipment fail, the other one can take its place. Within that equipment, we also want redundancy. We want multiple power supplies. We want multiple components within it. So if any component fails within that device, then the device is still up and running. And between our devices, we also want multiple lines. So that way, if any one of those lines goes down, we still have redundancy. The network still operates. The problem is when you talk about layer 2 devices like switches and you create two lines between those switches, it creates a loop. And so things like broadcast will cripple your network. It will bring it down to a crawl, or it just stop communicating altogether because of all of those loops that it creates and all the frames that are getting sent back and forth. And so what we need is something like spanning tree protocol to help mitigate against that, to protect our network, but allow us still to have redundancy within our network. So spanning tree protocol is pretty common amongst all of our networks of any decent size. It comes on your switches by standard. And so let's get into spanning tree protocol, what it is, and create once again that foundation for spanning tree protocol. In this video, we'll start out about talking about redundancy and what kind of redundancy we want within our network, and the problem when it comes to redundancy, what it creates. Then we're going to get into the spanning tree protocol, what the spanning tree protocol is, and start talking about how it mitigates against these loops that we can create by having redundancy. Then we'll go into some spanning tree protocol concepts, some things that you should understand. We'll get into bridge protocol data units. I'm going to have a video later on that gets much more in depth into that, but we'll just introduce what bridge protocol data units are. We'll get into the spanning tree algorithm, and then finally we'll talk just briefly about that there are different versions involved when it comes to spanning tree protocol. Now, just a refresher about what a bridge is. We're going to be talking quite a bit about a bridge and what a bridge does. Well, a switch is a multi-port bridge. So switch and bridge quite often can be interchangeable, really is interchangeable. And so as an example is this switch right here. What it will do is analyze the frames that are coming into it, take a look at the source MAC address, and record the source MAC address with the port that it comes in on. So that way it knows how to forward future frames forward onto that device in there. So a bridge allows this device to start learning. A bridge is a device that learns about MAC addresses and where the destination of those MAC addresses are. And a switch is a multi-port bridge. So just remember that those are going to be interchangeable as we work through spanning tree protocol. What we're going to do is we're going to work with the network diagram we've been working on, and I want to show you how I would incorporate some redundancy with this. All right, so what I would do is I would start creating multiple links between these switches. So between switch 2 and switch 1, I'm going to create a second line there. And that way, either of those links could fail and I'm still up and running. And I would, of course, do the same thing for switch 2 to switch 1, or switch 3 to switch 1. So now I've got multiple lines between these devices. But another thing is, let's say these are in different locations, maybe they're different buildings. I would also want to guard against this. Let's say quite often what will happen is a backhoe will dig up a line, or some line will get severed. And so now I need to still have redundancy, so it would go take a different route. And so what I could do is I could also create links between these two switches right here, and now communication can happen the other way as well. And this would be quite a few redundancies, right? And that's what I'm looking for within these networks. So I want to create this redundancy within. But the problem that happens here is when you have redundancy, a broadcast is sent out all ports except for the port that it comes in on. So an example between switch 2 and switch 1, if a broadcast comes in on this link right here, comes into switch 1 is going to then send it out all other links to include the one that goes back to this switch right here. To the one that goes back to switch 2. So that switch 2 is going to be receiving that broadcast again, and then it's going to resend it out all other links to include the one that it just sent it out on. And so now you see the loop. What happens is that this loop is created right here. Not only is it created right there, but it's going to have the same effect all across the network. We're going to get the same loops, and then also within the network. And so you can see how just one frame, that's broadcast frame that's sent out, is going to be sent over and over again, and it's just going to multiply within this network. And it will just continue to loop until it just brings down your network. And I've had this happen over and over again. And so what will happen is I've had like janitors during the summertime at a school unplug all the equipment, and when they plug it in, they just plug in things kind of crazy like, and they'll create loops, or you know, sometimes you intentionally, once again, you want to create redundancy within your networks, and then that creates a loop. And so all your smarter switches have spanning tree protocol. So let's get into spanning tree protocol and how it mitigates against this issue. So spanning tree protocol is the answer to fixing this issue. What spanning tree protocol will do is shut down some of the redundancy within your network, so that way you don't get these loops. And then if one of your links happens to go down accidentally, it will make this other link, this backup link, go live, and now you have connectivity again. So that's the spanning tree protocol. It does this in a few different ways. First of all, there is something called a bridge protocol data unit. A bridge protocol data unit is a frame that gets sent back and forth between the switches, and with some information to it that allows these switches to communicate and allow to establish which links are going to actually go down. And then we've got something called the spanning tree algorithm. The spanning tree algorithm are the actual steps and instructions it takes to shut down the links. So, and you need something like this. You need an algorithm so that each switch can make a logical decision on what links go down without causing problems. Because if they're working off of a different set of instructions, then what will happen is that they could potentially turn off the wrong link between them. They won't all be on the same page, and you'll create issues. So that's the spanning tree algorithm. So between the bridge protocol data units and the spanning tree algorithm and a few other things that we'll discuss, it really helps mitigate these loop issues. And so we'll get more in depth into each one of these aspects. Now, there's a few concepts you should understand when it comes to spanning tree protocol. So one of the first things is the algorithm. And we talked a little bit about this. This is just the set of instructions that each switch is using to base its decisions off of. We also have the bridge protocol data unit. We also talked about that. That's the frame that's being sent back and forth between these bridges or switches, carrying the information that tells these devices information about the different links and about the different switches that are within this network right here. Then we have the bridge ID. Each of these switches, each of these bridges will come up with a bridge ID, an identifier that is unique to each one of these bridges. So we got a unique ID, and based off of that unique ID, there's a lot of things that are determined. So for instance, one of the things that's determined is what is going to be the root bridge or the main bridge. So in this network right here, what I would like is that this main switch, I want everything to be going through it because it goes out to the rest of the world and then is routed into other networks. So I want this to be the main bridge or the root bridge. And so we'll talk about how to make that happen, to make that the root bridge. Then there's this concept called path cost. So there's going to be a calculation that's going to happen that's going to determine what the path is to that root bridge. So for instance, this switch will calculate the path cost that's going to the root bridge going via this direction and then also via this direction. And provided that all these links are the same speed, we're going to see that this is probably going to be the winner of those two, but we'll talk about what determines all of that. Then there's also this link failure and recalculation. So the one thing that has to happen with spanning tree is if one of these links goes down, then the other link can take over. The one that was shut off now becomes live. And so that is some concepts when it comes to spanning tree protocol. So what does the spanning tree algorithm look like? Well, here are the steps right here. I've already talked about a couple of these steps. First thing that happens is it elects a root bridge. The root bridge that is the essential winner, I guess, of this is going to be the one with the lowest bridge ID. So that's where the bridge protocol data units come in. Those bridge protocol data units are sent back and forth between these devices, and they carry information like what their bridge ID is and what the lowest bridge ID that they have found is. And so by sending this back and forth, all of the switches then get the information at some point about all of the bridge IDs that are on this network, or at least what is the lowest bridge ID. And they determine the lowest bridge ID. In my network, I'm going to want it to be this bridge right here, then is elected as the root bridge. From there, then the second step is to calculate what is the least cost to get to that bridge. And so what it will do is it'll add up the links to find out what the cost is to get to that root bridge. So from switch 2 to get to switch 1, it's going to come up with a certain cost. And then if it goes this direction right here, and then if it heads this direction through switch 3, what is the cost going to be there? Now, from this, when we look at this, looks like this is going to be that shortest path to get to switch 1, the least amount of cost, but that's not necessarily the case. What if these are gigabit connections right here, and this is just a 100 megabit connection right there? Well, then this is actually going to be faster. And so part of the calculation that calculates this factors in the speed of those links. So that is calculating the root path cost. So the cost of the path in each of the directions here to get to the root bridge. Then once it does that, then it's going to elect root ports. Okay, the root ports are going to be the ports that it's going to want to use to get to that root bridge. So it'll elect root ports to get to that root bridge, and then finally what it will do is it will elect designated ports. Those are going to be the ports that are going to essentially be receiving it. We're not going to get real in depth into this, but it's going to elect quite a few designated ports on here and then use those. And then once it elects those designated ports, those are the ports that are going to be up and running and receiving information, essentially, sending and receiving some too. Then it's going to elect alternate or blocked ports. This goes by many different names, but it's going to essentially, these are going to be the ports that it shuts down. So the designated ports are going to be the ports it's going to keep live. It's going to keep the root ports live, and then it's going to shut down some of these other ports. And then by shutting down those ports, it shuts down those links, so there's not communication between these devices on those links. It's not forwarding frames at all on those links. And then we reduce or eliminate that redundancy that's within this network. This slide has quite a bit on it that we're actually not going to cover right now. In fact, we're not even going to cover it that in depth later on, but I just want you to know that there are different versions of this. So Spanning Tree Protocol, STP, there's PVST, which per VLAN Spanning Tree Protocol, RSTP, Rapid PVST, Multiple Spanning Tree Protocol, MST. There's a lot of different versions that are around there. Just know that at this point in time, and we will be talking more in depth into this in the future video. All right, there was a quick foundation of Spanning Tree Protocol, and we're going to build upon that now. So some things that we covered, we started out talking about redundancy within the network and how it can cause some of these loop issues. Then we got into Spanning Tree Protocol and how it solves that. We talked about some of the concepts of Spanning Tree Protocol to include bridge protocol data units. We talked about the Spanning Tree algorithm and gave a brief overview of how the Spanning Tree algorithm works. And then we got into just briefly mentioning that there's some different versions that are out there. So yeah, Spanning Tree Protocol is pretty cool, and let's get more in depth into it with our next video talking about Spanning Tree algorithm.